Hey, what's up, guys? This is Sean here. So today let's take a look at this problem, number 853, car fleet. It's a media level problem. So you're given like n cars, and these n cars are going to the same direction and on a one-lane road. The destination is the target miles away, and each car has a constant speed here, okay, in miles per hour, and the initial position, and there's also like a ray here uh, represent the position of each car. Okay, so and the constraints like it's this: a car can never pass another car ahead of it. So which means whenever a car caught up catches up with the car ahead of him, it will it will drive bumper to bumper at the same speed. And the distance between those two cars is ignored. They're assumed to have the same position. Okay, so basically, let's say we have a car here, right? We have a car, and then we have another car here. Okay, and this is the target, right? And this is their driving direction. So by the time the second, let's say assuming this car has a faster speed, right? And then whenever this car catch up with this car, basically it will just be here, right? They will be bumper to bumpers, and they will be treated as the same car and at the same location. So they will keep moving forward at the same speed, which is the speed that's the first car having. Okay. Okay, so that's the constraints. And so whenever let's say more than one cars, and now those two cars are considered as a fleet. So and also a single car is also a car fleet. Okay. And if a car catches up to a car fleet right at the destination point, it will still it will still be considered as one car fleet. Okay, so which means that, let's say we have a car, uh, we have a fleet reaches the target destinations, and then there's another fleet coming to the reaching the target. They will be treated as a separate fleet. Okay, they will only be merging to one fleet before reaching the target. Okay, so and it asks you to find the how many car fleets will arrive at the destination. Okay, so for example, we have a target, right? There's a example here. Target is 12, and the position is like 10, 8, 0, 5, 3, and the speed for each car is like this: 2, 4, 1, 1, 3. So the final answer is 3. So why is that? This is because you know the the car 1 and the car 2, they will be they will form one fleet. Okay, and the car 3 itself is a fleet because here the target is 12, right? That's why the position is 10. So and with speed 2 here, so the arrival time for the car 1 will be what? Will be 12 minus 2, sorry, 12 minus 10 divided by 2. That's the arrival time for the first car, right? And the arrival time for the second car is what? It's the 12 minus 8 divided by his speed, which is 4. And this is 1, this is also 1. Okay. All right, that's why they can be forming into one fleet because they are reaching the target position at the same time, right? I mean, at the same time or equal or before the target. They'll all be considered as one fleet. So, and then another one is that so for car 3 here, right? Since the speed is 1, so the time for the car 3 for car 3 to reach the target is what? It's 12 minus 0 divided by 1, right? Which is 12. Right. So how about car 4 here? So the car 4, the same thing. So this is 3, this is 1, this is 1, this is car 2. So car 4 is like this. Car 4 is 12 minus 5 divided by 1, which is 7, right? And finally the car 5, sorry. The car 5 is what? It's 12 minus 3 divided by 3, right? Which is 3. Okay, cool. So as you guys can see here, right? So the time for 4 and 5, right? 4 and 5. So here's the observation, right? So when can a car so when will two cars merge as a fleet? The first thing is that, faster car. Faster car is on the left. Fast car is on the left. Is on the left of slower car. Okay, that's basically the conditions. A car fleet can be formed. So to be able to find the which car is on the left and which car is on the right, so the easiest way is we just do a sort. We sort by the position. Okay, so we sort by the position, and then we process from right to the left. And as long as we can see a car, the current car, right? The current car, which is the whose arrival time, it's smaller than the previous car. And then we know, okay, we have find a fleet. So which means that we can simply ignore the current car, right? Because it will be merged with the previous car. Yeah, and we keep doing that, until we have reached the first car, and then in the end, the length of the stack will be the final answer, because every time when we have a stack here, okay, so first we sort by this position along with the speed here, and every time when we have a car when we have a at the current car here at the current position here, we calculate its arrival time, and then we compare the arrival time with the first element, with the top element of this stack. If the arrival time is smaller, equal or if I mean if the arrival time is equal or smaller than the top one, then we can simply ignore that car, because we know that car will be merged with this car, right? And then in the end, the length of the stack will be our final answer. Okay, I'll try to start implementing this code here. So this is what I mean. Okay, we have a sorted, right? We sorted by the zip. This is like a helper functions in Python where you can zip two lists who have the same length together, and then it will uh, generate a combined list here. So I sort by the positions, and then we have n here of length cars. Okay, and then we have an answer here. Okay, so the answer is like a stack. Basically, I'm storing the fleet, the total fleet in this answer here. So for I in range of n minus 1 minus 1 minus 1. So the reason I'm traversing from the end reversely is because since we need to know, since the condition we are using here is that we want to know if the current car is faster than the previous car, which means the car on the right side. That's why in order to get the previous car's speed, we need to traverse from the end. Okay. Now we have the current car's position and the speed, right, equals to the car's I. And then we have arrival time, right? Arrival time equals to what? Equals to the target minus current position divided by s. Okay. So here's the condition here. So we only insert append to this current answer when what? If first is not stack, right? If the stack is empty, we do the insert. Or what? Or the arrival time is greater than the stack minus 1. Okay, and then we do the insert. Arrival time, and then we insert this arrival time. Okay, so this is the same thing, right? Like basically if the current car speed is faster than the previously car fleet, right? And then we simply skip that car. So vice versa, right? Vice versa. When the current arrival time is later than the previously fleet's arrival time, then we know, okay, we have so this car itself has to become its own another car fleet, right? So and in the end, we simply return the length of the stack. Sorry, answer. Okay, sorry, this should be the answer. Yep. So that's it. I think that should work. Position, positions. Okay, some typos here. Position. Okay. All right, accepted. Submit. Cool. Yep, that's it. I think this one is pretty straightforward, right? So, oh, and one more thing here. I mean, actually, we don't have to maintain this stack here. We can simply use like a counter here. That will also work. Basically, we use the counters, and then we also maintain the previously arrival time. So same thing. Anytime when the new arrival time is greater than the previous one, we increase the counter by 1, and then we update the previously arrival time with the current one, right? But I'm just using the stack here because it's a it's more clear for me. All right, so for the time and space complexity, I think this one is pretty straightforward, right? The Since we have a sort here, right? So the time and space is both n log n, because here it's just a log n here, right? So that's why the total time and space complexity for this problem, they're both n log n. Yeah, I think this one is it's simple like a sorting problem, sorting plus simulations. I can say that, or is there a greedy idea here? Probably not. I think it's more like a sorting, and then we just do a simulation from the end to the start. Yep, cool. I think that's it for this problem. Thank you so much for you guys to watch this video. Stay tuned. I'll see you guys soon. Bye bye.